Hello students, I am Dr. S.M. Bhatti. The objective of this video is to study properties of Laplace transforms and their applications. Let's see now third property, Laplace transform of integral. If Laplace transform of small f is capital F of s, then Laplace transform of integral from 0 to t of the function f of t with respect to t is equal to capital F of s upon s. That means if Laplace transform of function small f of t is known as a capital F of s, then we can find the Laplace transform of integral of that function ft with respect to t from the limit 0 to t is simply obtained by dividing this right hand side capital F of s by s. And if you take this L operator in the right hand side, we can have another formula, that is this. That means we can say that if inverse Laplace transform of capital F of s is small f of t, then inverse Laplace transform, that is L raised to minus 1, L inverse of f of s upon s is equal to integral from 0 to t function f of t dt. Let's see now fourth property of Laplace transform, multiplication by t raised to n. Here n is a natural number. So if Laplace transform of function f of t is equal to capital F of s, then Laplace transform of t raised to n into f of t is equal to minus 1 raised to n nth derivative of f of s with respect to s. There is note. In particular, if you take n is a 1, note that here n represents the order of derivative, and that's why the n should be a natural number, right? So if we take n is a 1, here we can have Laplace transform of t into f of t is equal to minus d upon ds of f of s. And if you change the position of this operator L, we can say that L inverse, that is inverse Laplace transform of d upon ds of capital F of s is equal to minus t into f of t. Let's see now example here. We know Laplace of e raised to 2t. It is 1 upon s minus 2. Now applying this theorem, that is a multiplication by t theorem, we can say that Laplace of t into e raised to 2t is equal to minus, you can see minus into d upon ds of f of s. Now what is f of s? It is a Laplace transform of f of t. So here Laplace of f of t is f of s. F of t is e raised to 2t, that is reflected in the left side, and right hand side we have to reflect this capital F of s, and it is possible by writing this minus d upon ds of f of s, and f of s is here 1 upon s minus 2, and you know derivative of 1 upon s minus 2 with respect to s is minus 1 upon s minus 2 whole square. So further the minus, inside minus and outside minus became plus, so we can get it is a 1 upon s minus 2 whole square. We can apply same formula again, and we can get Laplace of t square e raised to 2t as a second derivative of this function with respect to s, and that became 2 upon s minus 2 whole cube, right? Let's see example. Evaluate inverse Laplace transform of tan inverse of 1 upon s indirectly by using property 4. So property 4 just we are seeing, it is a you can see inverse Laplace of derivative, or one can say multiplication by t theorem. So it is easier to evaluate inversion of the derivative of tan inverse of 1 upon s. I mean to say that this tan inverse of 1 upon s is a quite complicated function. We haven't seen such a function before while obtaining Laplace transform, inverse Laplace transform. But you can see the derivative of this function. It is very easy. You can see derivative of tan inverse of s. It is 1 upon s square plus 1. Tan inverse of 1 upon s is itself a complicated function of s. But if we take its derivative, it became 1 upon s square plus 1, and you can see that inverse Laplace of this derivative is easy. It is just actually sin t. So tan inverse of 1 upon s is a function whose inverse Laplace is difficult, but its derivative is easy for finding inverse Laplace transform. So we have to make use of that Laplace of derivative property, that is inverse Laplace of derivative property, indirectly Laplace of multiplication by t property. Actually we want to find inverse Laplace of 1 upon s, but here is inverse Laplace, here is a derivative of tan inverse of s. Derivative of tan inverse of s is 1 upon s square plus 1. Right? Its inverse Laplace transform is quite easy, but we are interested in tan inverse of 1 upon s. So replace s by 1 upon s. So if you replace s by 1 upon s, or if you apply the derivative formulas, you will find the derivative of tan inverse of 1 upon s will be like this. Fine, we have to apply some derivative formula, and when you simplify you will find it is minus 1 upon s square plus 1. Fine, and then take the inverse Laplace transform on the both side here. So inverse Laplace of this is actually inverse Laplace of this is equal to inverse Laplace of this, right? But tan inverse of 1 upon s dash means d upon ds of tan inverse of 1 upon s minus sign. Okay, we can keep out, and inverse Laplace of 1 upon s square plus 1 became sin t, right? Now from equation 4, that means we are using the property here, according to property. Okay, because here we obtain inverse Laplace of d upon ds of tan inverse of 1 upon s is a minus sin t, no doubt. But according to property, L inverse of d upon ds of tan inverse of 1 upon s, I can take this tan inverse of 1 upon s as f of s, so that this became d upon ds of f of s, so that this became L inverse of f dash of s. And now by the property, L inverse of f dash of s, that is L inverse of d upon ds of f of s, is nothing but minus t into f of t. Now you can see that f of t is a inverse Laplace transform of f of s, and f of s is a tan inverse of 1 upon s. So you simply take this, already we obtained L inverse of this quantity, and here it is a minus sin t, and we keep the right hand side as it is, minus t, and actually L inverse of tan inverse of 1 upon s is a small f of t. So minus minus became a plus, and we obtain the f of t. F of t is sin t upon t, which stand for the L inverse of tan inverse of 1 upon s. So in this way we obtain L inverse of 1 upon s. L inverse of tan inverse of 1 upon s as f of t as a sin t upon t. Fine. To understand inverse Laplace transform of derivative property, or one can say Laplace transform of multiplication by t property, we can take one more example. The question is here, example is here, evaluate inverse Laplace transform, that is L inverse of ln, that is log of 1 plus 1 upon s indirectly by using equation 4. So what we will do first, we assume that L inverse of ln of 1 plus 1 upon s is equal to small f of t, and this is nothing but L inverse of capital F of s. Or one can say that L inverse of this quantity we are taking as L inverse of capital F of s, and you know L inverse of capital F of s is always small f of t. That means capital F of s will have the value ln of 1 plus 1 upon s. Now calculate d upon ds of f of s. That is d upon ds of f of s. F of s has a value ln of 1 plus 1 upon s. And you can see that derivative of this ln is very easy. It is 1 upon 1 plus 1 upon s into derivative of 1 plus 1 upon s, that is 0 minus 1 upon s square. And when you simplify that, when you simplify this derivative, because you just apply simple derivative formula here, and then you simplify that in partial fractions, we can write that as minus 1 upon s plus 1 upon s plus 1. Now we need to apply the property. We know that L inverse of f dash of s, so is equal to minus t into f of t. So this is the important formula, that is L inverse of derivative f dash of s is equal to minus t into f of t, right? And already we have seen f dash of, this is f dash of s, it is a minus 1 upon s plus 1 upon s plus 1. So its inverse Laplace transform is minus 1 plus e raised to minus t, and the right hand side as it is minus t f t, from which f of t can be obtained, and we are searching for f of t only. So this f of t represent actually inverse Laplace transform of this function. So last two examples suggest that there are some function like inverse trigonometric function, tan inverse, cot inverse, or logarithmic function like log of s plus 1 upon s plus 2, or log of s square minus 9 plus 9 upon s square plus 4. So if you consider the inverse trigonometric function, tan inverse, cot inverse, or logarithmic function, their inverse Laplace transforms are complicated, but their derivatives are very simple, so that we can find their inverse Laplace transform easily. So whenever we want to find inverse Laplace transform of a logarithmic function or inverse trigonometric function, use the formula inverse Laplace transform of the derivative d upon ds of capital F of s is equal to minus t into f of t. These are the references that we have used for preparing this video. Thank you very much for watching this video completely. Today we have used the properties of multiplying by t, dividing by t for the Laplace transform. Thank you very much.